Hello, hello. Good morning, good afternoon, good evening, everyone. It's been a minute. This is episode 10 of Let's Learn Networking, and we've shifted a little bit just to be a little bit more encompassing of other networking technologies in the cloud native, and even data center space. And we'll probably get to explore some other interesting technologies as we keep going. But one, I want to apologize to everyone for, taking a very long break here. But at the same time, I'm glad we're back. We're re-energized, we're ready to go. We're going to be diving into a little bit of BGP on top of Cilium with some Kubernetes magic, and yeah, we'll get going. How is everyone here doing today? Aakansha, how are you doing today?
Oh, I'm all good. Fresh start to the week. So excited.
Fantastic, fantastic. Dan, how are you doing?
I'm very good, thank you. Excited for today's session.
Sweet. And Leon?
Long time. So excited for the session again.
I know. What have you been all up to lately? I know, Leon, you've been traveling for a bit, right? Where have you?
Yeah, I went to South Asia and I went to a few meetups recently. The latest one was the GitHub Constellation, and I
Nice.
also attended like a platform meetup and all that for vCluster. So just going to try out all those things.
Very cool. How about you, Dan?
Yeah, been very busy with a lot of the Cisco onboarding and things like that. Now that I'm part of the Cisco family, and also eBPF Summit planning. So the CFP was recently announced for eBPF Summit 2024. So if people have ideas, we'd love to see them. Love to hear about them at eBPF Summit.
Yeah, I'd love to submit a talk, but I'll be quite honest. It's been a while since I've been playing with Cilium, and I was even caught off guard with some of the more recent updates, which was, one, exciting, but two, also like, holy crap, this thing is going really fast.
Yeah, moving faster than ever.
Yeah, and it's good because some of the key features that we're looking at with respect to Cilium are network engineering features that I think network engineers really wanted for a long time. And to bring that into Cilium, to bring that ideology, to make it familiar is huge. And on top of that, like I know you and Nico have put together, or actually was it Nico that put together this massive course or ebook on network engineering and Cilium and Kubernetes and stuff?
Yes, that was Nico, was that?
Yeah, it's pretty cool stuff. I got to go check it out. But I recommend folks, really trying to understand the networking side, go take a look at that book. Aakansha, where have you been up? What have you been up to? Where have you been traveling to lately?
So me went into travel for like Cube Huddle and then KCD Turkey. So it was all traveling then. And nowadays I'm again back to work and continuing my preparation for CK. So yeah, so
Nice.
I think I would probably give it on August or like September types. So
Sweet. Yeah, I'd love that. Because I need to, kind of go back in and probably go to attempt my CKA as well. I'm not a fan of the changes of the testing environment. They've made the CKA a 2-hour exam versus where it used to be a 3-hour exam. So you're more under time pressure. And like one of the interesting things about the real world is unless you're an SRE, you're not going to be under that kind of time pressure to jump around a lot. So it's quite interesting to see, what they're after with that exam. Anyways, it's still a fun exam. I mean, it's not multiple choice, it's hands-on. So you really got to know your stuff and you really got to know how things work in the Kubernetes, cluster and, how it's stood up and whatnot. So anyways, let's get to some of this networking magic. I'm going to share my screen and I should be able to see that. Let me know if you can see that. Yeah, awesome. All right. Love it. Okay. So one of the motivations for this stream is to, better understand how some of the networking technologies integrate with Cilium, especially when we're talking about stuff outside of the environment. Not everything is running in a container. Not everything is running in a VM. Some things might even be physical, and they might be directly attached to network devices. And those particular network devices should be able to know about that. There might be some feedback coming in. Please mute if you don't mind. I'm actually going to mute you, Aakansha. All right. So in order to be able to facilitate that communication, there's so many different ways you can achieve that. You could go the static route. You could depend heavily more on the networking side and just identify and indicate that there are some Kubernetes-based workloads or container-based workloads that exist in a cluster somewhere or in certain locations, and here's how to reach them. But sometimes you need some dynamic capabilities, right? Sometimes those networks will change, and it's only because you might have a burst of workloads, or you might have to spread your workloads to other locations, and you just need to be able to let the rest of the network know. And we used to be able to do this we still do this in the physical world. We used to do this with routing protocols, and the one in particular that we're going to talk about today is BGP. So let's get right into it. What is BGP? So it is a routing protocol that's used across the entirety of the internet. I mean, you might hear in the news when there are outages that BGP might be a part of the problem or a culprit, but it's also used in telco environments, in large data center environments. And the idea here is to move large network information. What do I mean by that? Or what is that large networking information I'm referring to? Dan, behind the scenes is asking me, what does BGP stand for? Isn't it like the Bridging Gap Protocol or something? No, it stands for Border Gateway Protocol. Dan, you wanna chime in and share some backstory there?
No, I just it's where we're entering the world of acronyms at the moment. I mean, you've got IBGP, EBGP, AS, BFD. It suddenly gets very overloaded with kind of all of these kind of acronyms that mean a myriad of different things, especially, and then there's all the various routing protocols as well, OSPF or ISIS. So I thought I'd just give you a quick prod just to see how you were doing.
No, I appreciate that. I actually do need a second coffee if possible, but I don't have anyone to bring me one, or I might have to, use one of those ordering apps, although I'm not inclined to spend $15 on a coffee. All right. So routing protocols are interesting because what we're actually trying to tell about other networks is about IP information. So how to get to these IPs, these specific host names that get translated into IP addresses at some point. We need to know how to route to them. And I'm basically jumping over a huge set of steps here, not talking about routing and IP in depth, but we'll probably have to revisit that in a later session. Everything has an IP address. Every device, everything that's connected has an IP address of some sorts. And that IP address needs to be findable. It needs to be able to also communicate outbound as well. Like whatever device is owning that IP or that address needs to be able to communicate outbound. And usually it'll use something called a gateway, a default gateway, to be able to get to an external network of some sorts. But the challenge, though, is that if that default gateway doesn't know about some of these remote destinations, you have to tell it. You have to manually provide that information. You have to manually say, these are the subnets that you can reach through this particular routing point or at this hop point. And if you actually look at the diagram, it's kind of indicative of what's going on here, right? We've got these workloads that exist with Kubernetes, and we have something over here on this side as well. And we have all of these red circles with arrows. These are routers, actually. And these routers represent, by the way, can you see my mouse moving over the?
Yes.
Okay, cool, excellent. These routers are those gateways I'm referring to. So I have let's say a workload here or a host here, and it needs to go find out about something here. Well, it needs to use this gateway to reach this destination. And there also needs to be a similar return path or a return path. Now, in order for that information to be translated over, well, this router, this device here, has to share this IP networking information over to this little individual over here, which would probably share it over here, and then it gets shared to the rest of the network. Now, obviously, we can control this. We can filter this. We can decide what kind of networks get sent out and how do we prevent, a situation where, because all of these different devices are communicating with each other and telling each other about the networks they know about, we also have to prevent something called a routing loop as well. And the reason why we want to prevent something like this is, let's say a packet gets thrown into the network and it has to hit all these routers. If there is no definitive path, or if there isn't something called a TTL decrementer, time to live decrementer here, what will happen is that packet will loop around the network forever, right? And that's one way to really stop it from looping. But the other mechanism is to just say that, hey, this path is not really available until this path up here, this primary path, goes down. Now, we'll get really complex here because BGP theory goes well beyond what I just defined. It's not just about neighbors, like these two devices here, which are neighbors, communicating with each other and telling each other about the networks they know about. We have to optimize it. We have to optimize for the amount of updates that occur. If there are constant network changes that occur here within this little network, do I need to tell this device over here all the time about it? Probably not. And one of the reasons why we want to avoid doing something like that, sending updates about the neighbors that come in and go out, is because it just becomes noisy. It's a noisy neighbor situation, which actually consumes memory and bandwidth and CPU. And it's because your logs get filled up with all of these unnecessary messages. And so one of the cool things about what BGP does is it filters the updates to send only the information that's necessary, and when updates occur, if it's necessary for the rest of the network. If there's a backup path that needs to be created, well, that'll go into something called a routing information base, which will also go into the BGP routing table. But the main routing table knows about the primary path, how to get to this destination. Now, I'm talking about a lot of like paths and how to get between different devices and whatnot. There's something interesting about this particular routing protocol. It has two flavors, IBGP and eBGP. You normally won't find IBGP running in a lot of data center or telco networks, only because it has slow convergence, meaning the update cycle takes a lot longer. And it's also one of those, there's a consideration around the fact that anything that is IBGP or internal BGP related is actually not a believable route. When I use the word believable, it's something of a routing thing where we have administrative distances assigned to every route. And these administrative distances will tell us, how believable or how reliable this route is, or how usable this route is, or if it's a preferred route. And the lower that distance is, the better that route is for us. Now, if we have an administrative distance of 1 versus an administrative distance of like 200, we're going to prefer the route that is 1. Now, there are actually interesting conditions where this might not be the case. Now, this actually goes into deep IP routing and IP theory. But when you actually have a very specific route, let's say you have a host route, a /32, something that goes to a specific destination, and we know what that destination is. We're not talking about a network. Even though its administrative distance might be a little bit higher, let's say 200 versus that less specific route, which might be a subnet route versus an actual IP address, well, we're going to take the specific route versus the subnet. Now, I want to leave this to a separate session because I think it's important that we dive into IP routing and IP theory and routing theory altogether. But we want to have enough time to be able to get to some of the hands-on stuff as well. Now, some of the other important facts about BGP as a protocol is, as it's sharing information about the networks it knows about. So remember, this is a router that runs the BGP process, and it knows about this network here, and it will share that information here. What we try to do with BGP is use something of a concept called autonomous systems. Now, these autonomous systems create a boundary which actually filter and help with the filtering of those routing updates, those network changes. So if there's something massive, like several network changes where massive networks we're talking about like actual subnets are being impacted, that gets communicated to the rest of the environment. But otherwise, those updates are filtered by this autonomous system boundary router here, which interfaces with other autonomous systems. And if you notice in the diagram, it might be a little bit tiny here. The connection between these two routers here is what we call an eBGP peering, or an external BGP peering. Now, this route is more believable because we define it as a network internet route kind of deal, or something that operates at a global scale. Now, there's something else that I want to talk about, is how BGP connects. Now, when we have devices that need to form BGP peer neighborships, we actually need some IP connectivity between devices. So I need to be able to ping from this device to that device. And as long as that's possible, then I can have BGP peering between these two devices. What actually is in between these two is irrelevant to me. Now, it might be relevant in certain situations where I'm trying to assess bandwidth concerns. But for the sake of peering, as long as these two are connected, and if they're two different autonomous system numbers, they're going to be an eBGP peer of each other. If they're the same autonomous system number, right, when I turn on the routing process, then they're part of an internal BGP peering process here. There's some other things to consider. Now, if I'm talking about IP connectivity here, if I am having a firewall that blocks connectivity in between the two, well, the thing is, BGP connects at TCP port 179, or at the TCP layer. So you can define a different port. By default, it actually uses TCP port 179. So if a firewall is blocking that connection, you're going to have to allow it, especially if you're trying to communicate between different autonomous systems. So we'll stop there with the theory. Dan, anything you want to add?
Yeah, so I suppose there's been a number of big outages on the internet. I suppose it's worth mentioning that BGP is basically the fragile system that holds the entire globe together when we talk about the internet and the large, massive network. So what, security-wise and things like that, kind of how has that happened? How have networks been taken over? What security is in place to kind of prevent these sorts of things?
If that's a question for me, I will say that, there's several mechanisms that exist to prevent this. One, like authentication, right? BGP peers support this level of authentication that have to just validate that the other end is a valid neighbor, right? And it's just through this MD5 authentication.
Mm-hmm.
In fact, there has been some improvements. I'm not sure if it's been incorporated into Cilium. I haven't gone that far down in the documentation yet. There have been improvements actually to improve upon that authentication, because MD5 actually can be broken pretty easily today. Now, there are other mechanisms to, like, who has access to these devices and who has access to be able to push updates to routers that get injected into the rest of your either data center or cloud environment, or even like the public internet too. And a lot of that gets controlled by organizations. Dan, do you want to expand on that?
I think you kind of largely covered most of it. Yeah, the MD5 hash is largely the basic method of ensuring that peers can speak to one another in a safe way. There's been a number of cases of kind of AS hijacking, things like that, where I'm trying to think if it was Facebook that went down because of a BGP issue. They basically withdrew some routes by accident or something or other, and all of a sudden various bits of Facebook and WhatsApp kind of stopped working. And even worse, I think all of like the door locks in their data center, I might be wrong, I can't remember if I read this right, but everything was all basically on these networks, and they withdrew these networks, and all of a sudden they lost physical access in their data centers into their security doors and stuff like that, because they'd withdrawn part of their internal networks by accident and stuff like that. But yeah, originally most of the BGP peering that we tend to think about was between physical devices. So BGP software running on your Cisco router or your other brand router. What we're now seeing a lot is software-based routing. So instead of having a physical router knowing about the network will have things like BIRD or FRR, or in the case of software load balancers, they tend to sit upon a piece of software called GoBGP, and GoBGP will do the sorts of things we've talked about. It will establish that TCP connection, and it will peer, and it will use an MD5 hash to validate who it is, and things like that.
Yeah, it's really cool you bring this up, because software routing really allows us to just create, software-based routers, virtual routers, either in containers or even VMs, that allow us to just bridge networking to these like various kinds of workloads. So yeah, on one hand, you're right. Like the software update cycle and maintenance is also the critical part too. Like, hey, if someone says, hey, now there's a vulnerability in this base image container, well, you're gonna have to update that, especially if it's running in your container environment or Kubernetes environment. There is a question from Siddhant. Since BGP has been there since the start of the internet, how has it evolved over the years?
Not a lot.
So it before BGP, it actually was called EGP, External Gateway Protocol. And BGP was more of an advancement in a lot of different ways for being able to be a little bit more resilient, implemented authentication. Some of the more advanced capabilities were to support IPv6 through multi-protocol BGP as well. Because look, the reality is we basically exhausted all of our IPv4 addressing, and there are a lot of organizations that are now using IPv6 on the front end on a lot of their hosted services. And there's a lot of systems that can dual stack connect in either way. And at some point, like, there is going to be a cutover. One of the interesting parts, though, is NAT seems to be entering the chat every damn time and slowing down the entire process. And it's not so much of a huge problem. It's just that NAT technologies in various instances can be very expensive. And I'm not talking about just cost, but like having to maintain them, having to, scale, a lot of different things to consider. And then also troubleshooting when issues come around. But BGP has evolved to accommodate some of the more modern protocols that are used today, and has just been used in a variety of different ways. In fact, a lot of cloud environments heavily use BGP, either behind the scenes or actually expose this to their consumers or their end users. So BGP in Cilium is interesting because over the years, it has evolved. Cilium didn't always support fully fledged, fully functional BGP. It had to use some external components like MetalLB to facilitate some of this. And then I think it was early last year, where the BGP control plane actually went beta and it was fully usable. You could actually set up peering connections. And then I find out, like, in 1.16, that entire thing changed all over again. And then there's a whole bunch of new resources. So what's interesting is, I will be honest, I was figuring this out this morning at around 7 a.m. my time, because I was like, wait, someone mentioned that BGP I think it was you that mentioned there was a huge overhaul. And I didn't think to click and go and double check like well in advance until this morning. And I started to realize, like, the BGP peering policy doesn't exist anymore. Well, it does, but it's going to be deprecated, and it's like, use it with a warning, because once we update Cilium again, it's probably going to be unusable as a resource or a CR. So, sorry, go ahead.
Sorry, yeah, it's pretty amusing. I mean, like, so when I joined iSurveillance to work on Cilium and things like that, MetalLB was, kind of embedded within there. When people wanted to enable it, MetalLB would be spun up, and then the engineering folks on the Cilium project, they implemented native BGP, building upon that GoBGP library. And then shortly after that, it was KubeCon, one of the KubeCons, I can't remember which one, where I was on the Cilium project booth, and I spent 3 solid days answering questions about BGP. It was like stepping back in time. But like, I had no voice left. Everybody was I was having to sketch diagrams, basically talking about everything that you've been talking about this morning. Because randomly, everybody was just so pumped up about suddenly having BGP running natively within Cilium. some people were just so excited about it, but didn't even know what it was. So it was kind of like, so I was having to, which is kind of weird, but yeah, having to explain what BGP is, and then people thinking about how they're going to use it within their infrastructure and stuff like that. So it's been on a journey, and it's evolving. There's kind of been discussions about kind of standardizing the BGP objects that you kind of mentioned, because there are a number of projects now. MetalLB still there, the Cilium that's now doing the BGP, whether we should try and standardize those BGP objects across all of the different vendors, kind of like we've done with Gateway API, so that it becomes easier for one person to potentially manage different clusters that have different implementations and things like that.
Yeah, no, you're absolutely right. Like, I think the methodology and mindset of network engineering has made its way into Cilium just to be able to address a lot of those network engineering concerns. Like, how do we make this more familiar for these audiences to be able to consume and use? And I saw some of it, like, it was very easy to recognize a lot of the original configuration when working with MetalLB, and then when the original BGP v1 came out. And then now when I look at BGP v2, it's impressive to see like how it's been broken down appropriately. So there's a lot more like, there's flexibility and customizability in how you want to. For example, like I'm going to talk about some of these CRs shortly, but like the node configure override, right? Or the node override configuration, whatever that CR is called. You set your policy for all nodes in your cluster, and then you override one by one, especially if you have like specific workloads that are attached to that one node, or it's doing something special, or it's running GPUs and whatever it is, right? So very interesting approaches. Let's dig into some of that and just talk a little bit about what the BGP function in Cilium is doing. So it's simple enough that we've got all of these workloads that run in Kubernetes, and we need to tell external workloads how to get to these Kubernetes clusters, right? We could do that through static routes, but one of the cool ways that we do this with is BGP. So BGP will take the pod siders and even service siders. And when I'm talking about service siders, I'm talking about when you spin up a service of type load balancer or something of that nature. We want to feed that to the rest of the network, because we're assuming an internal network, that it's not completely public facing, but you have internal workloads, both containerized and non-containerized. And what we're effectively doing is we're sharing those siders to Cilium. Cilium shares that to an upstream router. That upstream router is going to share that to the rest of the network. And all of that is facilitated through the BGP protocol. So what has to happen is these two routers here, the green one that you see is also a router, or better known as a top of rack switch, or layer 3 top of rack switch, whatever you want to call it, something high grade or high powered. And then you have this router that exists in Cilium. Now, I don't know if the virtual router instance exists anymore. I have to go back and check, and maybe we could explore that in the lab. But the idea here is whatever siders it knows about on this node, and this node, and this node, get shared up to this router through BGP, and then simultaneously gets shared back to the rest of the network. So that's one key capability, and then there are a few others that allow you to do things like eBGP multi-hop. Maybe you don't want to peer directly with this device, but you want to peer with a device that might be further upstream to skip a neighborship or communication between or through an intermediary. There's IPv6 support as well. And then one of the cool things is you could specify a load balancer IP pool, where if you have services using the service subtype load balancer, it'll pull from that IP pool, and that IP pool actually gets shared as a cider to the rest of the network. So in a lot of ways, that load balancer type is kind of providing your load balancer service. What's interesting is I personally haven't been able to test this out with something like a service mesh, because if you're using like an ingress gateway and it uses a load balancer, like, could we route to that load balancer IP if it's a service sider? And I have to do some more testing, but I think it's possible. And I think someone wanted to do a talk on that with me at KubeCon, but I was not able to commit to that for the limits of KubeCon and how many CFPs you can submit. So maybe we'll try that for for Cilium Con because there's still time. All right. One last thing is you can enable the BGP process with Helm. If you have Cilium already installed, just do a Helm upgrade and also a Helm update so you can pull down the updated repos and go ahead.
I suppose one other thing, if we kind of look at your diagram here, is if I'm trying to access one of the load balancer IP addresses that I've created a service of type load balancer, that IP address has been pushed up to that top of rack switch. Now, anything in network A, B, or C, when they try and access that IP address, they will know to go to that top of rack switch. Oh, they will know to go because the routes have been published. What will also happen is that top of rack route will also provide a type of load balancing to all of the nodes that are actually appearing as well. So you get kind of free load balancing. It's not the greatest of load balancing. It will largely kind of round robin between all of the routes that it knows about. But you do get load balancing from that top of rack switch down to all of the nodes that are actually peering with it and pushing those routes to it.
Yeah, and I'll add that this is not a complete representation of what a data center or a cloud environment looks like. You would have redundancy with multiple routers, and something like equal cost multipath would be enabled to facilitate that load balancing. So on one hand, you're making use of all available bandwidth. On the other hand, you have reliability or availability if one link or switch or whatever it is fails. So, all right, let's move on and let's just cover some key CRs or custom resources. So previously, I think it was confined to like one resource, which was basically the Cilium BGP peering policy, and maybe like one others, like the definition of your IP pools and whatnot. With more flexibility, they broke it down into a few other CRs, the BGP or Cilium BGP cluster config, which actually goes on to define the BGP instances and peer configurations as well, like between your upstream routers. So you're basically defining your upstream peers as neighbors. And that's something you actually have to statically do. There isn't like an auto discovery mechanism like you would see in other routing protocols. In this situation, you define your neighbors and as needed, define your networks that you want to advertise to the rest of the network. And then you could go on to define your peering settings, right? You could define the port numbers, the actual autonomous system numbers that you're going to be using, if they're internal BGP peers or external BGP peers. And then you also have the Cilium BGP advertisements as well, which we're not talking about the spam. We're talking about like actual network prefixes or subnets that we need to inject into the BGP routing table. And if there are redundant routes, well, the most believable route or the most specific route gets chosen and put into the actual main routing table. And then if you decided that you had some overrides that you needed to, use or take advantage of, this is where the CR comes in, or the Cilium BGP node config override neighbor comes in.
Yeah.
You'll find this in much more advanced environments. I don't know if the lab specifically that we go into explores it, but
I don't believe it does. But I think the why that kind of actually exists is there's you may, I think you kind of briefly touched on this earlier, but if you have a large cluster, you may be spanning some different networks. You may need to be pushing stuff to a different set of networks as well. So you may have like 5 machines that are built for a single particular purpose. They're all part of the same cluster, but they need to push their routes to a different area of the network because they've got GPUs and they're doing something AI related. You'll basically want them kind of isolated from what it is that the rest of the cluster is actually doing.
Exactly. So there are actually a few different resources that are interrelated and the need to work together. I talked about a few of them, like the Cilium BGP cluster config resource, the BGP peer config, the advertisement, and the node override. There are several others that you'll dig into, like the BGP node config, if you wanted to be a little bit more specific about a setting for that node. Or if you're trying to define your IP pools and what CIDRs you're going to be advertising back into the rest of the network or your external network. But to better understand the relationship a little bit better, the Cilium BGP cluster config and the Cilium BGP node config CRDs are effectively used to define a base configuration for BGP within the cluster on specific nodes. So you need those two to get going. They're like operator-based configs. So once you have that establishment, then you could enable maybe some of your other power users or developers to set up their own like routes or set up their own peering relationships and whatnot. So you can, if you want, the documentation is available to dig into all of these different resources, and I'm going to explore some of them right now for you, so you can see how this is all constructed. But we're also going to dig into this into the lab as well. So the first thing to note is to be able to just install BGP or enable BGP. We just need that one flag set BGP control plane .enabled equals true, and that will turn on the process, even if you already have BGP installed. Cilium installed. This is the BGP cluster config. I actually meant to hook up my pointer so that I could just highlight like the specific sections, but whatever, I'm just going to highlight them. So, or I'm just going to cover them specifically. So, standard configuration, v2 alpha, Cilium BGP cluster config is your CR name. This is the actual name of what we're going to call it. So if you just did a kubectl get Cilium BGP cluster config, that would show up. And we also have a label here, rack 0. So this is more for like data center operators to be able to identify where this particular cluster lives. And let's say they're trying to do some external monitoring, they'll be able to quickly identify when there's a failure in a cluster or in a particular node. Here we have something called the BGP instances, and what we're defining here is our local autonomous system number, something that's locally significant to us, so that we can identify ourselves to our peers. Hey, we are autonomous system number 6500, and I'm going to connect with you. And then if I have a peer right here, which is also the same autonomous system number, what does that mean? That means it's an IBGP peering here going on. So you normally would probably find this in a data center environment. And if we're talking about a few routing protocols or just one routing protocol that exists here, that convergence isn't of a massive concern. It's still an IBGP peering. And if you notice here, we're peering up to 2 different devices. One is Tor or top of rack switch 1, and the other one is top of rack switch 2. And what's really interesting is if you notice, they have a peer address here. This is actually not an IPv4 address. This is not a hex address or a MAC address. This is an IPv6 address. And it's actually specially denoted because you see the 0:0 here, which means it's just the shortened form. But what it's just telling you is that these are the peers that we're going to connect to. And on the other end, on these 2 devices, the mirror of that would show up. So meaning this device's IPv6 address would show up as a peer or be the peer for these 2 devices up here. So I log into these devices and we would see them as peers. Now, what else did I want to show here? Nothing here. Okay, so here's the peer configuration. Now here's where we start to get a little bit more specific about what the peers can do. And these are more like negotiations to ensure that both peers are aligned. And quite honestly, like not everything has to be present in this configuration. Some of it's mandatory. Like for example, we need to make sure our timers are matching on both ends, because if they're not, then the neighborship will never form. But the reality is these timers are really here to help us with the updates, how often we send updates, how often we're checking for neighbor keep alives. There's also some other settings too, like the transport layer protocol and port that we're going to be using. So we're using TCP, and normally by default we'll use port 179, but let's just say we want to be a little bit more secure and we're going to be using a non-standard port that no one knows about. If we go back to Dan's question, what are some mechanisms we can prevent like some security instances or incidents from happening? Well, maybe don't use the default port 179 because someone might try to form a BGP peer neighborship over that port. Graceful restart. Oh, actually, before I touch graceful restart, you see that auth secret reference or secret ref here? So you're actually creating a Kubernetes secret that stores the MD5 authentication hash or password. and it's called on in this BGP peer config. So the other end has this password or passphrase. You also have to match it, but it just gets referenced from that secret you create in Kubernetes. All of this is in the documentation, by the way. All right, graceful restart. Now, there's something interesting about routing protocols. Before graceful restart ever existed, when a neighbor goes down, it's an indication because of the keep alive that, hey, this neighbor's down. I'm going to remove the routes it's told me about because the neighbor is no longer accessible. But what if you're just doing like a maintenance window? What if you're just restarting the control plane and you still want to just make sure those routes are there because you're not changing any of the networks? The neighbor is not dying. It's just a maintenance window. And we want to just make sure that, those routes are still there so that data will still flow. So graceful restart enables that. We could actually restart the routing process, the routing engine, without like flushing the routes. So if you flush the routes, they disappear. But what this tells me is that, okay, my neighbor is going down for a certain period of time. I'm going to keep the routes in place because I know it's going to come back online. So I won't do anything. I won't renegotiate. This means I won't have to resend routes again. This means I won't have to tell the rest of the network about these changes. This also means I cut back on unnecessary bandwidth usage. So this is interesting because these little tunes, or this tuning, helps in so many different ways when you're actually setting up something as advanced as the BGP protocol. There's a couple of other things too. I don't think it's specific to this configuration, or maybe it can show up here, is bidirectional forward detection. BFD is another interesting protocol which actually lives on top of routing protocols. It lives ahead of them because we need to still tell neighbors if they're alive. And if we could do that quicker than our protocols can, tune their timers or adjust their timers or even count down, well, we could quickly resolve a situation like an outage. We could figure out a secondary path. We can inject a backup path rather quickly versus having to wait for the routing protocol to renegotiate and determine what that new path is. Everything is could be down to a subsecond in terms of reconvergence. And this could be very important in high transactional environments where a sub-second outage means oh, we've just lost $1 million in revenue or sales or something to that effect. I'm going to call out one more. Actually, I'm going to pass it to Dan to talk about the address families, if you want to talk about that.
So I mean, this, I find the whole BFD thing kind of amusing a little bit. It's we've got timeouts, but now we need super timeouts. There we go. But yeah, I say the two don't necessarily live together. It's kind of funny that there's been in the Go BGP community, when are you going to implement BFD? People have been asking for it 6 years, and it's we're not going to implement it in Go BGP because it's a separate thing altogether. But so in terms of families, I think these are effectively I believe they're the type of routes that we're actually going to be advertising, whether they're IPv4 or IPv6 routes.
Yeah, it's just a way to kind of distinguish routes and determine how you best route them or advertise them to the appropriate neighbors.
Yep.
So say for example, you had a set of routes or a set of neighbors, and you only wanted to advertise your IPv6 routes to your IPv6 neighbors and your IPv4 routes to your IPv4 neighbors.
Yep.
You would use the address families to be able to do that or achieve that. And it's an oversimplification of doing that, but you do this in situations like you're running a large telco or service provider environment where you're handing out VPNs to various companies and organizations, but it's all using the same physical fabric. And you need something like route targets and distinguishers and even address families to be able to distinguish from that and create some separation, so to speak, almost like routing virtualization in some regards. And then you get into this idea of virtual routing and forwarding, which are VRFs, which I don't think we have available yet okay, that's fine.
No.
All right. I'm going to cover one more resource, and it's the peer advertisement, and then we'll get right into the lab. Now, this particular resource is interesting because here we're defining what CIDRs we want to advertise back into our physical network outside of Kubernetes. Now, there's also something here called the local preference, and I don't want to get into all of those details at the moment, but you can actually influence the path of routing for BGP using different attributes. There's actually a list of BGP attributes that exist, like local preference, weight, MED, or something. I forgot what it is. Medium something determinant. I can't remember what it stands for. It'll come back to me eventually. But all of these different attributes help determine the best path for you to take from router to router. And you could influence that. You can modify that in certain ways. You can add weight to increase you could add weight so that it actually decreases the likelihood. I can't remember what the ordering is. There's a mechanism which, like, if you actually increase it, there you go. Multi-exit descriptor. That's what it is. Thank you, Ajit. MED stand for this. And then there are just several other attributes that you can take advantage of to be able to influence your paths. Now, one thing to just be aware of is that, like, with respect to how much control you have over, like, let's just say you're a Kubernetes operator and you only have access to your cluster. If you don't have upstream access, if you don't have access to your top of rack switches, that could be a problem for you, especially if you're trying to troubleshoot, like, let's say a peering configuration or peering misconnectivity or lack of connectivity or something of that sorts. But here's, like, the reality is, like, this is where we're trying to make this so much more easier for you to be able to consume and just say, hey, like, I have access to YAML. I have access to maybe some of these other devices like FRR, where I can do some additional testing and even test out some of these, like, attributes to, determine, let's say, the best path around the network. And I bring this up because if you're doing, like, advanced network testing and scale testing, especially for a variety of style of networks, I think Container Labs helps with that. And you can even write that into a bit of CI/CD to be able to further test that out. All right. We're going to get into the lab, but I just want to do a quick plug. We are doing a Twitter space on Thursday with Bill from iSurveillance as well. And we're going to dive into some of the more historical aspects and what's going on with the Cilium space today. So feel free to join us, scan that QR code, and we hope to see you there. All right. Dan, do you want to do the lab or do you want me to do it?
I've just looked at mine, and because I've not touched it for 45 minutes, it's timed out.
All right. Let's see if mine is going to time out. But for the folks in the audience, if you have any questions, feel free to chime in and ask away, and we'll try our best to answer them.
I suppose a quick thing for people who are, kind of, what are the alternatives to BGP if I have a network? And most people, when we talk about, I guess, service-type load balancers and exposing addresses in an on-prem cluster, people tend to kind of go down the route of either saying layer 2 or layer 3. When they say layer 3, they're largely kind of thinking of BGP because it's connecting over TCP and it's exposing ports over routing and things like that. The alternatives being layer 2, which are effectively ARP, which is different to BGP. And with that, you are effectively letting the local network know that one of your machines that's in a Kubernetes cluster is now hosting your service type load balancer address. The main differences really are BGP requires equipment. You need a top of rack router that speaks BGP in order for you to push those sorts of things. So if we're thinking about home labs or small networks, then it makes more sense to kind of consider layer 2 or ARP for doing the exposing of these addresses. In bigger networks where you have these routers, you're largely going to be considering BGP in order to facilitate those sorts of use cases.
Yep, I am working to increase the font size. I noticed that sometimes even for me, it's a little too small as I, age with the universe as well. So we have our cluster up and running and we have our nodes. I'm sorry, it's really hard to see our nodes, but we have 4 ready to go. And I'm actually going to just get another, it's still not ready. Why? Oh yeah, we haven't installed Cilium, that's why. Okay, that's on me. So that's the next step. We've got our cluster up. We have to deploy Cilium and Container Lab. So Container Lab is interesting because it's a Docker-based environment that runs containers, but these containers are actually routers or virtual network devices running as containers. Now, what's interesting is Docker has some really cool networking that you could set up where effectively all it's really doing is using bridging. And you can stand up multiple different networks where you bridge these different routers together to simulate various LAN, WAN, data center topologies. And you also get access to a variety of different of like virtual network devices as well. So if we are actually going to use and take a look at the topology file that Container Lab gives us, and it's going to go ahead and deploy it. It's a long file, but what it's actually doing is it's taking these configurations and applying them to containers it's going to deploy. For example, in this case, it's actually deploying the FRR container, free range router, right? It's a virtual router that can be deployed as a VM, that can be deployed on bare metal, it can be deployed as a container. And it's actually, as it's deploying as a container, it's going in to modify some additional configurations for it so that it's got access to the external network or these networks as well. And then it can go about routing appropriately to a local device, and then a few other configurations as well that we're seeing down here. So this configuration below, if you were to log on to a physical router, and you would do that either through SSH or through like a console cable, which actually, Dan, if you don't mind filling the gaps, I'm going to go run downstairs quickly and grab my console cable, and I'll be right back.
Yeah, sure. So, what we're kind of looking at here effectively is we stand the image up, we have it actually running, and then we effectively apply our config against this. So yeah, as Marina is going to kind of show us in a second, when you first get your expensive networking switches and things, you need to actually configure them for the first time. You will need to log in there, set all the default security credentials and things like that. And then you typically will need to go through the fact of saying this selection of ports belong to this particular network, this selection of ports belong to a potentially different network. You may create VLANs, so like this 6 ports are part of VLAN for production, this 6 ports are part of VLAN development or testing. And if we want to have traffic that will cross those 2 different virtual networks, we will tend to actually say traffic coming in from this VLAN we will allow it to be routed to traffic that exists on this particular network as well. So what we're really kind of doing here is we're configuring a router. We are saying, here is the router's address. We're giving the routers their AS numbers so that we know that what particular network that they're part of. And we're also saying, kind of traffic coming from these networks are also going to be allowed networks. So I think what Marino is actually going to go get is an RS-232 cable. So if you have never set up a switch for the first time, typically it won't have any networking information. They also don't really come with screens or keyboards. So there's only really one way of configuring a switch for the first time, and that is through a serial cable. Have you managed to find one, or?
Yes, I did. So let me show you all. All right. So this
is it the blue Cisco one?
Well, yes, exactly. So this is a standard Cisco switch, a little Cisco plug there for Dan. But if you look back here, right, there's actually a serial a port, console port, and it looks like a little Ethernet plug, right? But this is actually what it is. So you have this blue cable that when you get like a Cisco, when you get a Cisco device, this blue cable ships, right? And look, the reality is, if you look at the other end, what device has this now? Does your MacBook have this anymore? No, absolutely not. So what you have to do is you have to get a USB to serial RS-232.
It's amazing. It's like 2024 and we're still shipping 30-year-old cables.
Hey, you know what? There's a lot of network gear out there in the world that still use this, right? It's just it's interesting. A couple of comments here.
Someone's completely confused at this point.
What's going on here? So we jumped around a bit. I wanted to point out, like, if you were to work on a physical router, you would actually need a console cable. Sorry for the sidebar and tangent there. That tends to happen on these streams where we actually have to configure a device. Now, in the case of this, like, let me reshare my, dang, how do I do that again? Okay. In the case of this configuration, right, like we log into the device and this is what we're pasting. From here on end, we're actually adding configurations around IP routing. We're actually adding configurations around addressing, right? And several other bits too. In fact, if you go further down, there might even be configurations for the device on, oh, maybe that's later on for BGP. Yeah, maybe not now. But we come back and reconfigure BGP. But what this entire container lab configuration or topology file is doing is defining the container-based routing network. So it's actually going in to configure Docker networks. It's coming in to set up those Docker topology networks as well. And it's defined right here, right? Like the endpoints and what they're connected to. So router 0 net 0, which means router 0 network interface 0, because we're developers and we always start at 0, is interfacing or directly connected to Tor 0 net 0, which means the top of rack switch 0 and its network interface 0. And we just keep doing this. It's like that. You can think of this as a wiring at this point. So as long as this wiring occurs in Container Lab, when you actually go on to ping devices through their respective interfaces and try to ping what's on the other end, it will go through, right? This is just a more static definition of that hardwiring. But the reality is, like, if you're in the physical world and also in a little bit in the SDN world, you're going to be programming a lot of this as well. And it won't be as static as this. It won't be just like, hey, this to this, this to that kind of wire deal. All right, so let's go to the network topology tab and take a look and see what's going on here. So we actually have a number of devices. This is a, oh wow, interesting. Yeah, I didn't know we could do this, but let's see what we can expand out. Now, what we're actually seeing here is just the connectivity of all of these different network devices. And it seems like top of rack switch 1 has the most connections coming out of it. And I think each of these SRV worker 2, 3, these are our nodes in our cluster. So these are the endpoints. And in fact, I think my dog's coming upstairs. I was just like, who's walking around the house right now? If you think of these little circles, these are our nodes in the cluster. Right. Now we're going to deploy the network topology. I think we already did. Oh no, we actually just viewed it right now. So let's go ahead and run this. And it's actually going to get it up and running. And we can go ahead and check our connectivity as well. And this is cool because I'm also going to show you something here, like this Docker exec command. When you run a Docker exec command, you're actually execing into some sort of terminal, some sort of environment. You're actually execing into a shell of some sorts. This same concept is present in the physical world. When I need to connect to a device, I will either SSH into it and I'll connect to the shell of it and be able to configure it live. Now, things look to be good. Let's copy this command. Docker exec interactive. Oops. This is the router device that we're connecting to. I think this is the FRR router upstream. VTYSH, right? VTYSH is the virtual terminal for SSH. Is it? No, not SSH. It's the virtual terminal for the shell to be able to get into the actual router itself. And then we're actually running a command. We're passing a command, show IP BGP or IPv4 BGP, or sorry, show BGP IPv4 summary wide. God, that's a mouthful. Okay. All right. So we're sending and receiving some sort of messages. There are two neighbors here, which makes sense. They probably are the devices that know about each other, and that's about it. We haven't done the rest for Cilium yet, and we're almost there, though. What it's also asking us to do is run a couple of other commands. I already did that. I already did that here. So let's go ahead and deploy Cilium. So all we have right now is we've established basically BGP on our upstream devices. That's it. So our top of rack devices, the physical switch that I showed you, assuming that it supported layer 3 and BGP, would have BGP running on it. Oh no, they're using 1.15. Okay.
Oh, the lab hasn't been updated yet.
Yeah, that's okay. All right. What I'll do for the next stream then is actually get it running with 1.16 and then show you the differences between the two. But this should at least illustrate to you that, this is the BGP routing process. This is how it, connects to Cilium and upstream routers. There's a couple of things I also want to point out when you install Cilium, right? You actually have to disable tunnel mode. Now, by default, when you enable Cilium, assuming you just use the defaults, it uses the VXLAN overlay, meaning all of your nodes form VXLAN tunnels to each other, or maybe Geneva. I don't know if it's actually Geneva now. I think it was one or the other. Anyways, at the end of the day, it's a virtual.
Is the default.
Yeah, it's a virtual tunnel between multiple nodes. So you can think of it as an n-by-n relationship. So if you have 5 nodes, each one of those nodes has a connection to the other node through this VXLAN tunnel, similar to an IPsec tunnel. Now, the reason this happens is to actually enable all of these nodes to be on the same network, right? Enable your once your nodes are on the same network, once they have established that VXLAN connectivity, your pods that get deployed, regardless of the node that they're on, will be on that same IP network. So if they move from node 1 to node 2, that IP network doesn't change for them. Right now, here's the reality though. When you actually redeploy workloads, they may not always have the same IP, but that subnet still spans the entirety of that network. Now, one of the reasons you have to disable it here is because when you want to enable the BGP process, you actually now turn each one of your nodes into its each individual own network almost. Because what happens is each node gets its own CIDR or pod CIDR that has to be reshared back into the network. So if you have 3 nodes in your cluster, each one of them is going to have its own pod CIDR, its own unique pod CIDR. Now, you're not going to have different pod CIDRs across different classes of networks because that's impractical. You probably want to have it within the same 10.x.x network so that you can summarize your routing updates up to your physical network. A couple of other things too, the IPv4 native routing CIDRs, they're set as well. We have set BGP control plane enabled equals true. By the way, if you are installing Cilium for the first time, you can do this. If you already have it installed, that's where you use the Helm bit to actually enable it from a pre-installation. So let's go ahead and run this. I'm gutted that I didn't check about this beforehand because I was looking at the repo for I think some of the BGP examples, and it has a make file, which actually will just build the entire environment for me. And I was toying with the idea of just doing this on the fly. And now that I think about it, I kind of wish I did. So we're going to check on the status of Cilium. It's going to take probably another minute or two before it fully is up and online, and then we'll check some of the status and settings. And I think we should be able to wrap this up in the next 10 minutes or so. Yeah, okay, final quiz. Okay, fine. I will do the final quiz just for fun. Okay, Cilium is up and online. Let's check and see that, okay, BGP is enabled. And then let's also check our nodes, because remember, our nodes weren't ready yet because the CNI was not installed. So get nodes. Yep, everything looks good. Let's go ahead and check, and we'll move on to the next section. And folks, feel free to keep adding questions to the chat. I am more than happy to take them on. Dan has just stepped away for a minute. He'll be right back. Okay. This is what I was talking about. So in 1.16, we don't use the Cilium BGP peering policy, but before 1.16, and you're probably using 1.15 right now, or 1.14, the Cilium BGP peering policy is the way to go. In fact, if we take a look at it right now, we can see what that peering policy is. It's almost similar to the BGP peer cluster config in that we're defining our peers, and their specific addresses and even their autonomous system numbers are autonomous system number as well. The difference here, though, is that now we're actually injecting our pod CIDR information here, or the kinds of CIDRs we want to advertise upstream to our physical devices. That's where we're indicating this here. Whereas in the configuration I showed you previously, the more updated one, that's broken up into its own Cilium BGP peer advertisements CR, or custom resource. So in this situation, this is where I was talking about a lot of that BGP configuration was confined to a single resource, and now it's been broken down into several others for 1.16 and beyond. So we've got the BGP peering policy. Let's double check something about the nodes that we have. And what we're really looking for is the nodes with the affected, or with the applied labels rack 0 and rack 1, because these are the nodes we want to peer with and want our peering to happen with the upstream routers that we deployed like previously, the FRR routers. So let's go ahead and deploy the peering policy. Let's go ahead and validate that BGP peering is running. And we're going to actually do this from the perspective of the top of rack 0 router that we deployed. So if I copy this, remember, I'm logging into the router now. I am not talking about Kubernetes. I'm talking about the container router I created. And now we can see that we have a BGP peering relationship here. And it's telling us it's the CLab BGP control plane demo control plane node, which is this one right here, as well as the worker number 1, which is here. And if we actually did a kubectl get nodes wide, if you look here, right, this is the IP that matches this one right here. Same for this one over here. So we actually know that peering is working. We could just validate the same for the second upstream router. Peering is working as well. And we're actually going to run the NetShoot pod because I think it wants us to do some quick testing. So we've got NetShoot out there. And we're just going to wait for the pods to come online. Question from Ajit: how long does this go on for? First time joining, so don't know. We usually try to do this for about 60-ish minutes or so. This will probably just go on for another maybe 10 minutes more, as we're almost near the tail end of it. But I wanted to show that BGP is established. The one thing to point out is this is based off of Cilium v1.15, and I'm going to revisit 1.16 next week and how it extends up BGP, and we'll probably just do it from scratch and dig right into some of the details there. All right, NetShoot's rolled out. Let's verify end-to-end connectivity. And I think we're just gonna, let's copy this command and tell them what is it gonna do. Our source pod is anything with the control plane demo worker part. And then we're gonna store that as an environment variable. And then we're going to do the same for the destination. So we're going to go from any of our control plane workers over to worker 3, I believe. Oh no, demo worker 1 to worker 3. Okay, and then let's execute a ping. Oh, I see what's going on here. We're actually execing into this control plane worker, which is, I believe, part of the container lab. All right, let's see what happens if this ping goes through. Yep, the ping goes through. So meaning, I just want to double check and see who that thing is. kubectl get pods -o-a. Nodes. C-plane demo worker. Wait, who is C-plane demo worker? I'm gonna do something here. Okay, that's why. It's NetShoot. It's one of these. Okay. I was a little confused there. Okay, so we're actually going from the NetShoot pod, this specific one, directly to this worker 3. That's what we're doing. Okay, makes sense.
You're going to be
we should-
disappointed when you click that service announcement button.
I love it. Okay, all right. I was like, oh my gosh, is there like one nice activity? Okay, we'll move on to the final set of activities. But it looks like we do have. That's it.
Yes.
Is that it?
That's it.
Oh my gosh. Okay.
So we
Let's go
effectively
back.
set up the entire environment, and then it's another lab for actually doing the load balancer IPAM and actually doing the services.
Okay. So let's see something here. Cilium BGP peers. BGP peers. All right. So this is stuff we didn't even get to dig into, and I wanted to point out something very important here. So the reason we run these Cilium BGP peer commands, one, to give us familiarity with how to use BGP by using the Cilium utility, because now I look and see that, hey, I am interfacing with my peers, right? This is these are my wait, this doesn't seem right. These don't seem like my peers. Where are my upstream peers? Wait, where are my upstream peers? Cilium BGP. What else? What else? Oh, routes. Ah, okay. This is interesting. I want to look at my topology for a second. Can we go back and look at that?
Yes, I don't think it's going to. There you go.
Yeah, I'm very curious on how this is all set up. So there are my top of rack routers, right? Did we not set up routing between the two? You know what? Let's go back to that module here. Let's do a Docker PS. Okay, so we've got okay, I'm going to do this. Docker exec HIT. What is it? Bash? Damn it, that's not what it is. What's the argument I can pass in?
H2SH or something or other at the end of it. You don't need the dash, just do SH.
Oh, yeah, that's right. I keep thinking this is Kubernetes. There we go. Okay, so I'm in here. Actually, I realize it's BTYSH.
Yes. Yep.
All right, BTYSH show IP BGP neighbors. Show IPG summary. Is there a summary keyword? Dang it. Let's do a summary. Just trying to correlate my.
Yeah.
Okay. Here we go. Okay, so we are seeing our neighbors, and are we getting our routes? Show IP BGP routes. I think that's another command that I can run here. Okay.
There you go. Yeah.
Looks. Yep. So it is working. So I'm seeing that I'm learning about networks from my demo worker 2 and worker 3, and right now I'm on Tor 01 or Tor 1, which is the second router. So effectively, yeah, it's working. I just I'm gonna have to talk to Nico about how this lab ends so abruptly. But there it is, folks. Now we have Cilium and BGP deployed together with FRR as a top of rack router, which isn't very visual. But hopefully maybe we can improve upon that experience for next time and just actually dig into the 1.16 instead, because that's not what I was expecting. But let's just do the final quiz for fun. Cilium's BGP control plane is activated by default. BGP can be used to export pod setters. True. What do y'all think about this one? Is this true?
Yep.
Cilium BGP peers are configured using a Kubernetes CRD, correct? This is incorrect. And this is correct. Wait, actually, as identifiers. That's a tricky one.
I mean, I'd say yes, but
because
it is a unique network. It identifies the network, doesn't it? I suppose. Does that mean we got it right?
I guess so. I don't know.
Oh, okay.
Final exam challenge. What? There's now a final exam challenge. Okay. All right. Well, in this practice exam, you have access to the kind cluster. However, the BGP peering policies have been removed, and you have to set them up and deploy them again. Oh gosh, I did not anticipate this.
Well, I mean, this is largely what you're going to do in the next lab anyway, because we're going to be setting it up.
Yeah. Let's come back to this. Oh, it looks like they already have a sample configuration here. But this is here's the thing though. I don't want to take Ember's like, I hated these. Okay. Thank you for the great session. I found that Docker makes the admin job so much easier. Yeah. I'm actually curious about security plus drone. Yep. I feel that too. I never pursued the security plus, even though I studied for it. I just gave up. So I'm like, I'm not a security person. Anyways, thanks for coming along, Ember, and thanks for everyone joining. What we're going to do next week, let me stop sharing. What we're going to do next week is or the next session, we want to come back and explore that 1.16 and re-explore some of those custom resources, the newly minted ones, because that shows us how flexible Cilium BGP can become, especially if we're trying to do upgrades or make changes, or we have to service a node for whatever reason, like it's going into maintenance mode. But I want to just thank everyone. Thank you all for joining for this misadventure.
Sorry. Yeah, in the 1.116 as well, there's a lot more troubleshooting information in the Cilium CLI. So, why aren't things peering? Did I forget to do a password on my peering config? Is something wrong or whatever? A lot more information is now kind of visible through the Cilium CLI in order to troubleshoot why things aren't behaving as expected.
Exactly. Leon, Aakansha, any questions, thoughts before we wrap the stream?
I'll be very honest, this all went over my head. But I will try to figure out once I run this in my lab or something like that. But generally this is all very low level things for me. Like, I mean, I know it's a virtual BGP and all that, but it's still very low level at this point. But I will try.
Fantastic. All right, Aakansha.
I agree with Leon. A lot of stuff went over my head as well. But yeah, I need to work on my fundamentals before I jump into this low level. So yeah, but yeah, it was pretty great. Thank you.
Awesome. Well, thank you all for joining again, and we hope to see everyone in the next stream. And yes, Ember, you absolutely need to join earlier next time, because there was a lot of boring slides that I showed much earlier on. No, next week I think I'm going to next time we do this, I'm going to just skip the slides and just go right into an environment, and we'll just start figuring things out. But thank you all for joining, and I hope you all have a fantastic week. Take care, everyone. See ya.